Hi, my name is Larry Moody, and this is my presentation on adaptive health management as an emergent technology for the MIS 580 class, Washington State University Executive MBA Summer 2013. My presentation will cover 6 general areas related to this technology. First of all, a summary. Second, a description of how it works. Third, advantages and disadvantages. Fourth, comparison with existing and similar technologies. Fifth, applications. The applications are shown on each chart rather than broke out as a separate category. And then finally, a chart on future potential. Adaptive health management is the use of IT capabilities to determine the future state of components of an overall system, such as an airplane or even a business. This knowledge is then used in various ways, including real-time adaptation to accommodate component degradation and identification of on-demand maintenance needs. The application shown on this chart is the Phase 1 or the Block 1 GPS satellites launched from 1978 to 1988. These satellites incurred a non-repeatable noise event that was found to precede failures of certain components. Eventually, they learned that when these noise events occurred, they needed to move quickly to reconfigure the vehicle or the spacecraft to use different components so that a failure could be prevented. There are 3 ways that this system, health management, operates. The first, or 3 steps in how it operates. The first is a computer processor is embedded in the system and runs a simulation of the system and its components in real time. The actual responses of the system then are compared to the expected responses of the simulation. And if the responses differ by a predetermined margin, then the system responds in a way that reduces any detrimental effects. This can include, say, switching to other components or simply flagging a component for maintenance. The application on this chart is the health management techniques to the 2nd generation reusable launch vehicle program that NASA had pursued but is canceled as a replacement for the space shuttle. It was intended to increase the efficiency of the onboard decision making and logistics management. Advantages and disadvantages. As an advantage, it allows the completion of the system's primary mission despite unpredictable failures and degradations. And it also enables components to be replaced or maintained when they actually show signs of degradation, which is called condition-based maintenance, rather than on a conservative and more costly schedule. Disadvantages. If this system is implemented poorly, it may fail to inform the people that need to know of the adaptation that was provided to accommodate failures. And this can hide problems and lead to belief that the design is okay and everything within the system is working properly. It also adds cost and complexity. The application shown on this chart is the Gulfstream G650. Gulfstream and General Electric teamed up to use health management techniques for monitoring and responding to the engine anomalies. Comparing this with existing monitoring methods, for instance, the existing monitoring methods do not have the same ability to reconfigure the system. If I compare it to existing control system feedback methods, which do reconfigure the system, however, they don't provide any predictive ability. And then if I compare it with existing maintenance scheduling, of course, that's generally schedule driven and does not actually consider the component behaviors. And the application I'm showing on this chart is the Army M1A1 Abrams tank. And the reason is that the Army has undertaken a project to retrofit this vehicle and the Bradley M2A2 fighting vehicle with health management techniques to reduce maintenance expenses. Future potential. This technique can be used in, say, computer networks. If you can deterministically model the response of the computer network, Then an adaptive health management system could be employed to correct the bugs and programming mistakes in real time. Medical applications. Pacemakers. Pacemakers are already being developed which communicate with a wireless device, but the frequency and magnitude of the pulses can be modified to make the heart beat according to an ideal model. And then say train scheduling. Train scheduling may be better able to accommodate unexpected delays and construction with this method.